Hello everyone. Now let's go with starting of three-phase induction motor. In the case of an induction motor, at start when the rotor is at standstill, the squirrel cage rotor is just like a short-circuited secondary. Therefore, the current in the rotor circuit will be very high, and at the same time the stator also will draw a high current from the supply lines if full line voltage were applied at start. The magnitude of this current depends on the electrical design of the motor and is independent of the mechanical load. The duration of starting current, however, depends upon the time required for acceleration, which in turn depends on the nature of the driven load. Well-designed induction motor will usually take about 5 to 7 times the rated full load current at the starting if a rated voltage is applied to it. Best way to reduce the starting current is to apply reduced voltage across the starter winding at start. With the reduction in voltage applied to the stator of an induction motor, the short circuit current will be reduced in the same proportion. The major factor to be considered if we employ reduced voltage for starting of squirrel cage induction motor is the large reduction in starting torque. Since starting torque is proportional to the square of applied voltage, whether or not such a large induction in starting torque is permissible will depend upon the applications. There are several methods of starting of three-phase induction motors. The most commonly used method are given below. Squirrel cage induction motor. A squirrel cage induction motor having primary resistor starter, direct online starter, auto transformer starter or auto starter, star delta starter, rotor resistance starters. Then slip ring induction motor, it contains rotor rheostat starter or rotor resistance starter. Let us see the primary resistor starter. The primary resistor starter use of primary resistor is to drop some voltage arrayed, hence reduce the voltage applied across the motor terminals. In this way, the initial current drawn by the motor is reduced. By using primary resistor, the applied voltage per phase can be reduced by a fraction x. Then the starting current, full load current of ratio or the starting torque to full load torque is square of times obtained with direct switching or across the line starting. This method is very useful for the smooth starting of small machine only. The protective device from the figure shows on the screen the connection for starting squirrel cage induction motor using primary resistor with the protective device incorporated. In consists of 3-line starter, 2 set of 3-line conductors, 2 contactor, a time relay, overload protection, a push button station and several auxiliary contacts. So this is primary resistor starter. Next we have to see a direct online starter. Sorry. This is the most economical method of starting of induction motor. Squirrel cage motor of capacity up to 2 kilowatt. Double cage motor or squirrel cage motor of large capacity having very high rotor resistance are started by this method. As the name implies, this method refers to switching the motor directly onto the supply without using any device for reducing the starting current. Now, the starting torque is given uh, rotor input 2 pi n and starting torque T start proportion to current starting square. So if IF is the full load current and SF is the full load slip, when the motor is started direct online, the starting current is equal to the start short circuit current ISC. Note that starting current is largest 5 times the full load current, but starting torque is just equal to the full load torque. Therefore, starting current is very high and the starting torque is comparatively low of this large starting current. It may overheat the motor and damage the insulation. It has some typical control circuit of doll starter. A doll starter with a protective device included to start the motor. It is merely necessary to press the start button. This energizes the M contactor through the overload relay contacts OL normally closed, which in turn close the main contact M. Many also close to seal the main contactor so that the start button may be released. Overload protection is provided by two thermal elements placed in the motor leads. If there is any overload, motor may get overheated and now at this instant. Thermal elements open the contacts in the control circuit to de-energize the main coil. This opens the M contacts and disconnect the motor from the supply. Third one is auto transformer starter. These starter are also called as auto starter or compensators. It consists of an auto transformer with necessary switches. This method can be used for both star and delta connected motor. Reduced voltage for starting can be obtained from 3 auto transformer connected in star. Voltage is reduced to a fraction x of the rated voltage Vs. The motor starting current is I start equal to XIC. The tapping on the transformer is so set that when it is in the circuit 65% to 80% of line voltage is applied to the motor. At the instant of starting, the changeover switch is thrown to start position. This puts the auto transformer in the circuit and thus reduced voltage is applied to the circuit. Consequently, starting current is limited to safe value. When the motor attains about 80% of normal speed, the changeover switch is thrown to run position. This takes out the auto transformer from the circuit and puts the motor to full line voltage. Auto transformer starting has several advantages: low power loss, low starting current and less radiate heat. For large machine over 25 HP, this method of starting is often used. Auto transformer may be either manually or magnetically operated. Relation between starting and FL torque. Consider a star connected screw cage induction motor. If V is the line voltage, then voltage across motor phase and direct switching is V by root 3. And starting current is IST equal to ISC in case of auto transformer. If a tapping of transformation ratio K is used, then phase voltage across motor is XV equal to root 3. It is found that while the starting torque is reduced to a fraction x square of the obtainable by direct starting. The starting line current is also reduced by the same fraction. Compared to the primary resistor starting, the line current reduces further a fraction x while torque remains the same. The autotransformer starting is much superior to primary resistor starting. Also, smooth starting and high acceleration are possible by gradually raising the voltage to the full line value. Thank you.